easiest way to start, and I always do that, is what we're not. Most filtration system is precipitation, coagulation, filtration. It's really simple. It's you dose an oxidant, typically chlorine, go lots of contact time, precipitate out iron and manganese, and filter it. Yeah, it doesn't matter if it's a sand filter, it's a membrane filter, it's green sand. There are a lot of systems, and that's how most of them work. That said, that's not what we do. We do what's called absorption. And in the absorption, what we do is we have a very short contact time. In fact, we have more contact time. Chlorine, typically, we chlorinate just before it goes in filters. So, and what will happen is chlorine is the best oxidant. Iron precipitates out fastest, so you will, most of your iron, you have about 1.5 milligrams of iron. So recall, your iron is 1.51, your manganese is 0.21. So you're going to precipitate out a lot of the iron that's mixed on top of the filters. And then the rest of the iron and the manganese is going to be removed by absorption. This media, if you activate it, and that's what we're doing with chlorine, is the active has absorption sites, and the manganese and the remaining of the iron will actually attach to the media on those absorption sites. It attaches with a weak ionic bond, so it backwashes off really easy. So what we do is you create the best conditions for absorption during filtration, and then when you do backwash, you mess that all up, and so it breaks between changing the amount of chlorine that's in the vessel and the flow rate and the all those things. It breaks free and it goes out through backwash. The media is what we call AS741N. Pyrolops has lots of names. It's mainly dioxide oil. It's ground and screened. We spend most of yesterday getting all the fines out of it, or most of the fines out of it. We'll notice today because we will do an automatic backwash, that there's a little bit of gray. So what we're going to do is we'll leave you probably set up the backwash every 12 hours at 5 minutes a vessel. That's going to be way more than what you need based on what we're filtering. But we're going to do that until we get the rest of the manganese dioxide out. Because that will read as high manganese. So, and then we'll also talk when we get over to the backward section. We'll talk about how to set the length of time. There are two things if you don't get anything else today, the two things you need to get. One is chlorinate, chlorinate, and chlorinate. One of the first thing that will run this media is the lack of chlorine. That means that the pump goes, we pump belts and it pumps for a couple hours, and we run the media. No, it's either doing that a lot. We have a customer that is having a lot of problems with their chlorine feed pump. Oddly enough, never had it after 3:30 in the afternoon. Never had it after 3:30 on a Friday or before at 7:30 in the morning on a Monday. Never had a problem with it on a holiday. And one of the first things I did when I started working for ATEC was let out help to change the media because we're chlorinating. So that's, you need chlorinate. I can't say that enough. That's your first key. What we're looking for, my understanding is you don't have any ammonia or hydrogen sulfide. So what you're looking for out of, the sample port that isn't a sample port right now, but your treated sample port, you're looking for a minimum of 0.50 milligrams of weighted free chlorine. 0.5. You can have it higher. You can have it as high as you like, actually. We had it yesterday at 7.95 or 6.95. But everything was going up. None of it was going to the system that year. The MCL was 4. So Canadian Health cares if it's over 4, your customers are going to care if it's really high. But at 0.5, you have taste got to be pretty good, and it's going to be safe. But what we're doing with that is you're activating the media, and that's important. The other thing is you have 42 inches of media in each vessel. That means that these are 60 inside walls that you measure 18 inches down. And then we'll pretend this is the top of it. So if you measure 18 inches down, the top of the median ought to be about there. You know that because every 6 months you want to kick off the well, depressurize it, pop the excess ports off, and measure that. What I typically do is I measure from here to the top, add that to my 18, and I report that. It's in your O&M. There's the maintenance, suggested maintenance stuff that's in there, but I do that every 6 months. There's one thing that keeps the median, and that has to be that gate valve. That's your control valve, and it is on top of these vessels. There's below that throat valve is a 20 opening, but there's that's opening in there. There's a splash plate. Other than that, there's not a screen or anything. That flow is what keeps your median in the vessels. If you backwash it out, I don't know if you can access your backwash tank, but if you can, you can go pick it up, put it back in, but you don't want to do that. Your backwash rate is 3.2 liters per second, which is the equivalent of 50 gallons a minute, which is 28 gallons a minute per square foot. Don't ask me what it is liters per second per square foot, but anyway, 3.2. And once I said it yesterday, we ran it forward. We'll recheck it today when we do backwash. And it'll vary a little bit, vessel to vessel. We're ballpark. The nice thing is you have an air gap so that you can always check to make sure you're not getting media through. Once you set it, you have to go over it. Below there's an under drain. Other than that, as far as the vessels themselves go, filtration. So what we're going to do is we're filtering through all four, come down, we'll check your water quality here, and we'll talk the system, and where to go. So that's the start. The backwash valves. And let me give you a diagram. And what? Sorry, left out. This is a blown up. What you have is the Drone 51 series. It was what you're looking is probably 6 to 8 years life before you're looking at doing a rebuild. You can get kits for it. I do not recommend that you have a kit on the shelf. There's a diaphragm and the seal. And the rubber parts in about 2 years will be non-usable, or will be suspect at best. Yeah, you can get them anywhere. You can give me a call and go, I think we need to rebuild one. Send me a kit, or we do have some folks that just every 6 to 8 years we get 4 kits and rebuild them. You want to do that, you can do it. Or you wait maybe have an issue. But that's as simple as what it is. Now you can have a copy.
Oh, just need a video of it.
Oh, I'm not taking any extremes, but so what happens is we have airlines run to the front of the way the backwash system works. We backwash one at a time. So your well is going to do with both wells on let's say you're at 3.8 layers a second. When we're in backwash, we'll put a little air to the front of the first one. We'll backwash typically between 4 and 5 minutes per, never less than 3. And so what happens is we put some air, the piston slides back, blocks off the supply side, opens it up to the backwash line, which is the atmosphere. We said we have a control valve, we set that flow rate at. So we watch this at, say, 5 minutes. When that's done, we let that one open back up. We close it off to supply here, and so on and so forth throughout. Assuming we're leaving the controller on constant power, if, say, you lose power out here, and you're on number 2, we did 5 minutes here, we did 5 minutes here, we did 5 minutes on 3, or we're doing 4.5 minutes on 3, and we lose power. That's out for 6 hours. 6 hours later, everything's restored and we're back up and running. That controller is going to go, oh yeah, I was backwashing. So then it will reinitiate. It'll be 5 minutes on 3, 5 minutes on 4, and then rest. So it's pretty simple. The biggest problem you have with the valves, other than they've been there a long time, you have to keep in mind the diaphragms. Take anything and do this good enough times, it gets weak. The other thing is eventually it'll get weak or you'll get a little pinhole in it, and they don't work quite as well. If that's the case. The other thing is the seal on the back. We operate with their. We found that we're at 100 psi on the compressor, which is operating the valves fairly quickly without, you don't want it to slam. With the Drone wants about 10 psi above operation, and we're operating just under 90 and we're about 100, so they seem to be working really well. So, yeah, typically what you want with air pressure, you want the minimum amount of air pressure to operate the valves fairly quickly. You don't want to have it hanging up. You don't want to let them either. That seal on the back, you'll get a mouse bite out of that, and you'll start leaking water by. Then you'll be rebuilding. You'll see that being a real big issue with the way we have it set. These are clean outs. If you ever had to take the media out, you log out the wells, you open the top, you open this, but you don't want to do that. So you're going to keep it backwashed. Second case of keeping this media operating. I can't tell you how long it'll operate, but it'll be a very, very long time. Providing you do the second thing that will ruin this is backwash. So if you backwash well and keep it coordinated, you ought to be golden. There's only one other thing, which is probably not an issue we're going to test for it, but silica can be an issue with the media because what we found is if you have high silica and high pH, we were testing yesterday and we were about 7.2, and there was telling me that it might be below 7. Actually, I would use the test curve. So if that's the case, I'd be really surprised if silica is an issue. But so you know, in the interest of education, that what happens with silica is it will also attach to the absorption sites, but it doesn't backwash off. So if you had an issue with silica, then we would do one other thing here. We add an additional chemical which does a little protection for manganese up front, which ties up the silica and keeps it from attaching to the media. Otherwise, over time, the slowly gets less and less effective. But don't think that's going to be an issue here, but my understanding is that we have some reagents for it. We'll test it. It's easy to test for you. Essentially what we do is we test the law and read it and see if there's any difference. And that's how you know we're leaving media on the media or not. So that's the other thing is these are still tanks. You can get your spray paint, but this is industrial blue. There's ANSI gray. You can get that at any hardware store, any auto parts store. So we can send you some, but it'd be a lot cheaper to get locally. But if you get any rust on these, you do want to keep them cleaned up. Eventually, they'll rust through. We've had folks that had to send them in because they didn't do that, and over time, it takes quite a while. This is fairly thick, but you get holes in them that got to be repaired. And if you end up sending them back to us, what we do is we sandblast them and repair them and rebuild the whole thing and send them back. So, but it's easy to keep. It's a wet environment. You have caustic material. You have chloric acids. It's just the way things are. Keep it looking pretty. If at least hit it with some Rust-Oleum or something. You don't care if it looks spotty. If you want the same color, get pretty. As I said, we can send you a can of the cardinal paint, or we can get some local. I'm sure they'll do as well. Yes, sir.
Copy it doesn't work.
Nope.
You red green it?
No. So anyway, that will be Well, we have gauge in and out, but that will be your yearly account. You're going to get to know and love that one as well as one of the chemical room, which is raw. We recommend that at least the first 6 weeks you do weekly iron, manganese, and free chlorine. After that, you kind of just do that at least weekly. Even systems that have chlorine analyzers, we recommend that you chlorine on a weekly basis. And my understanding is that while you do have a chlorine analyzer, chlorine meter, and then you have your initial satellite test and that works fine. But if you want to know what your removal is, we've got after this incident, it will be important on how often you backwash, whether or not you can extend the time that we backwash. Then if we move this way, oh, yeah, little pictures I have. Okay, so this is your controller. Real simple. It's printed circuit board. The controller panel itself is 12 volts AC. Your solenoids are 24 volt AC. We have 110 going in. There's a transformer that's stepping down to 12 volts and 24 volts. If you still have power here and these aren't working, one of the things you're going to do is you're going to check in here and see whether or not you're getting 24 volts to these when they're activated. So the controls are really simple. There's an even 4 box. I generally keep it closed because it's powered and water inside a controller is not a good thing. There's the F8 electronic control panel. It's pretty robust. It does have a battery in it, which you may or may not need depending on how we end up with backwash. But essentially, what you're going to, this will give you some information. Right now, we're in the idle mode, which means that that's the same thing as filtration mode. It's been 16 hours and 42 minutes since the last backwash. This clock starts when the first vessel starts backwash. So there are several ways this will backwash. One is off the timer, which we set here. This is periodic time. Currently it's in off, but if we were to turn this to 12 hours, then every 12 hours that this is running, it's going to initiate a backwash. The other way is if you push this black button, that is the way that you want to come in and I want to backwash. Push that button and it'll show you the backwash cycle. Another way to backwash is if we turn one of these quarter turn, that's going to initiate a backwash. We also have a remote start coming from your PLC to here, so your PLC can initiate a backwash. And we have a pressure differential switch, which is set at about 8 psi differential. A lot of if you have any familiarity with other systems, it's like your pool filters or sand, they typically are running off pressure differential. A lot of systems use pressure differential as a primary trigger. We only use it as a backup. The reason being is by the time you get enough pressure differential to initiate backwash, you're at or near breakthrough. Breakthrough is when you're at the MCL. For manganese, the MCL is 0.50 milligrams per liter. For iron, it's 0.30 milligrams per liter. And we don't want you to be, no point putting dirty water into the reservoir. So our belief is that we shouldn't do that, and that's why this is only backup. If you end up with 8 psi, then there's something going on, and usually the fix is doing the backwash. If it backwashes based on this, if you walk in and it says alarm here, that tells you you backwash based on pressure differential. The way to clear that is you put that down in the alarm reset, push that button, and it'll reset it. And then put it back and run. The other thing is, this in idle, it's going to give you backwash cycle count. It's going to tell you lap time since it last backwash. If you want to reset the backwash count, you may or may not want to. It's really easy. Push it all the way down to the back. Watch count reset. It tells you exactly. You push that button, and it went from 11 to 0. Put it back and run, and when we backwash today, it adds one when it completes all four vessels. At the end of it, it'll add one. So if we were to, if I were to cycle this through, I could add one. The circuit breaker, in case, it gets stripped. If you have power outage issues, if you have a lot of power outages, you may want to consider, putting some type of surge protector. If you have a lot of problems with that, you can't take the panel out. Your power surges. Controls are easy. The first one is periodic, where we talk about frequency, how often we're going to do it. You can set anywhere from quarter hour to 48 hours. And we'll figure out, by the time we get done, Eric will tell us we'll kind of figure out how we're going to initiate backwash and how we're going to make that all work. Figure out where we're going to set that. The next two is your duration, or what we call duration, which is how long. Top one is minutes. You can go anywhere from 0 to 15 minutes. Today we'll leave it on 5, and then seconds. So it's possible to go anywhere from 2 seconds a vessel, which really doesn't do anything, but up to 15 minutes, 60 seconds, or 16 minutes you can backwash per vessel. And then the last one is dwell. What dwell is the black part of your solenoids are electromagnets. So let's listen it up, and we'll talk about that in a moment. And the time between when it deactivates one and activates the next is the dwell time. Unfortunately, they only give us a 5-second dwell. So if we do 5 minutes per vessel, it'll do 5 minutes on this, wait 5 seconds, do 5 minutes on that. So essentially, when you get done, you'll let it backwash. This should read about 20 minutes and 15 seconds. And then, you can, if you have a problem and you need to stop a backwash, one way to do it is if you turn that off, power down, that'll stop a backwash. The other thing is you can push the black button. The first time I push it, it will do vessel 1. The next push takes me to dwell. The next button takes me to vessel 2. Dwell, vessel 3, dwell, vessel 4, then go to idle. And B, you can just go through it that way. That's okay. The reason why we have that's off is we want to pull this off. If this panel goes bad, you're probably calling me because it's going to be enough years down the road. I'm having this problem. What's going on? This panel has a little fuse. Keep in mind, this panel is 12 volt AC. It's really unhappy if it hits anything other than 12 volt AC. And you may or may not pull that out before you I have one that we just sent the electrician to direct fault contact to the transformer, blow out the transformer, blow out the panel. We don't have that problem here. Your electrician obviously knows what they're doing. The other thing that's important to note is the whole thing is fused. These are 3 amp ASC fuses, and you can see one here. Well, if I flip it up, you'll see that there are 2. The one you can see is your spare, and this one is the live one. And we do that so that, I don't know how far it is to the auto parts store or a Radio Shack or somewhere you can get ASC fuses, but you have spares. Besides that, if it's 3 in the morning, you're out here trying to figure out what's going on, or it's a holiday weekend, it's nice to have those. If you have an issue where you're not getting your power here, first thing I check the fuses. And then, if you blow one, put it in, away you go. This is 110 power, goes in through a transformer. One of these is 12 volt, but Another one is 24 volt. The top one is marked M. M is what electronics uses for master. It will typically activate, we have it now set up to activate about 16 seconds prior to initiating backwash. And the way we address that is, see there are blocks of dip switches. Up is on, down is off. So we have this one on, so it gives the PLC time to turn both wells on. The next one block is for pressure differential. All three are up. The reason why all three are up is that means that you have to have a pressure differential of 8 psi for 180 seconds or 3 minutes or more. That way, if it shuts down and the gauges, if I were to take all three of these down and we're got to the end of the backwash cycle and we're at 0, if this needle bounces up and touches there, it's the same thing as pushing the button, and you'll look through and it'll just go back into backwash. If you call me and say, "Jay, it's getting to the end of the backwash and going right back in," I'm going to ask you what these dip switches are. We know today, because we have on recording, that they're 180. Next block is, these are the dip switches that correspond to the numbers 1 through 8. These control your solenoids. If one of these goes bad, you have lots of choices. One is, if you want, we can send you a new panel, away you go. Not what I would do. One of these goes bad, I would say it's number 3. I'd take dip switch for 3 and kick it down. I'd move 3 down to 5, kick 5 on. Or you move 4 to 5 and 3 to 4, so they keep the same order. And these don't cost any more if there are 8 out or if there's 1 out. We're not really, saving money is really easy. All you do is move it down the way you go. These panels are pretty easy. If you loosen these screws, the panel will drop right out. There's only one way to plug this in. This is your pressure differential switch. The switch goes bad, which it occasionally does, not often. One way to figure out if it's that or it's something else, you can unplug that and see if you still have a problem. These are, I don't know how to say it off the top of my head, but they're fairly robust. They don't go bad very often. That can plug in only one way. And these are the wires for the remote start. The remote start is where your PLC does a momentary direct closure. If you get a new panel, we send you, one's a male, one's a female. There's only one way to plug it in. It really doesn't make a whole lot of difference on these, but we just did it so it's a lot easier, so that everything is. I know how to plug this one in. We're not going to run into a problem. So that's really all there is for that. Keep in mind these are 24 volt AC. Oh, there it is. Cool. So with that done, any questions about this?
My only question is, if we did happen to have a power outage while it's in backwash mode, will it continue the backwash once the power restarts?
What'll happen is, say we're on number 3 and you have power outage, power goes down, this panel's going to go dead. It doesn't care why it goes dead. It's really unemotional, the whole thing. It's, I'm dead. When it comes back on, it has battery in it. Battery is soldered in, but it's a lithium battery, and when it comes back on, it's going to power back up and go, oh, I was backwashing number 3, so it'll do 5 minutes on 3, 5 minutes on 4. Or if it goes down when you're on 1, when you get powered back up, then it'll reinitiate backwash. That's the cool thing about this panel. That's one of the many things I like about it. It's, as I said, it's really robust. And I'll put the nuts on it a little bit. Okay, so when this thing says it's going to initiate backwash, what it does, we just talked about there being an electromagnet in here. Those are getting rid. Okay.
That's a gross.
Yeah. You get it. Okay. is the electromagnet. There's a plunger in here. It's spring loaded. And the spring keeps it, see, on the bottom. On Peter Paul solenoids, 73 series, which these are, the ones with the knobs, that is always supply, that is always service, that is always exhaust. And what we've done is we've simply, as you can see, we took the plug and drilled it. And we turned it away from us because
we don't want to get sprayed with air.
Okay, so what happens is the electromagnet sucks it up. There's a seal on the top and the bottom of the plunger. Allows air to come out of the center, come off this side, and then goes up to the valve. When you deactivate the electromagnet, the spring pushes it back down, which opens up the top, lets the air escape there, which creates the pressure, and it goes into idle mode. One or two things will go wrong with these. Someday, it's like, we have a plumber in the room. So he knows if you have a washer and you keep sealing something, eventually you wear that out. And you have to replace that. There's a kit. It's a fraction of the cost of replacing the solenoid. Doesn't make a whole. Yeah, if you want a kit, you can get one. If there isn't anything that'll go wrong with the system, they'll keep you from filtering. It may only affect your ability to backwash. So the kit includes this, includes an O-ring, it includes the seal, and there's a keeper down in here because on the other side of this knob, there's a pin, and when you rotate that, it looks like someone took a paper clip and bent it all around, and it manually lifts it up. That's why turning this, that part will do a backwash again. F4 number 2 is going to get used. Use it. You take this off with a spanner wrench. How many of you guys are auto mechanics? Okay. Oh, yeah, that's close enough. So you know what GDT is. Gosh darn tight. When it comes to the solenoids, don't do GDT. If you do, when you take the stem and screw it into the valve body, if there's a seal, you just want it tight enough so that it's not going to be loose and that the seal will keep the air in there. If you do it really tight, then you're going to play heck getting that out without damaging the stem. You put a ding, you damage the stem, or you put a pair of pliers on it to get it off, and you have a dent on the inside, and this plunger sticks going in, up and down, and you're replacing your whole valve. So that's one thing to know. The other thing is your tap. We do have a place here. When you put this on, there's a spacer, and if it loves the spacer, it gets really upset if you don't have the spacer here. You're just going to tighten this until it doesn't rattle easy. You just make it snug. So when it comes to solenoids, be gentle, snug only. The problem is, if you get this really tight and this isn't, when you undo this, what's going to happen is the valve body is going to fall down, and the bottom of the stem is going to be sticking about here, and all you're going to see are the threads. So the trick is, how do I get something on the threads without damaging them, so I can get some off here and get those apart. The reason I know this is I've done it. They don't put this in the book, wherever the book is. They go, oh, go out and change these. And, I'm used to, I was an auto mechanic for a lot of years, and it was okay, everything. Tighten everything. If you don't have a torque spec, you tighten it down as tight as you can. Not with these. Be gentle. The other thing is, most likely the first thing you'll notice And when we used to do these hydraulically, not pneumatically, it take about 5 years. You're probably looking 7, 8 years. You may eventually get a little air leak through here. There's no ring on here, just a standard O-ring. And if you look underneath, you'll see there's a set screw. Take a little screwdriver. The set screw is about so long. Take it out. Take this out. Put an O-ring on it. Put it back in. Make sure the pin is goes under the little keeper in there, so that it still works. And set it back in, and away you go. That's really the only thing you're going to probably end up doing with these. And you may, if you're not, I don't know how often you use this or not, but yeah, they're, as I said, probably looking 7, 8 years, I'm guessing, before you have an issue with the O-ring. I'm guessing you go out to your truck, you have O-rings, it's just as good. It's cheap, it's easy, away you go. These are pretty robust, same as those are pretty robust, so that's why we use them. It's no fuss, it's no must. Essentially what you're going to do is you're going to operate the system, make sure it's coordinated, make sure it's backlogged properly, monitor your removal, because that's going to tell you everything you need to know. In case you have a problem with one of these, just so happens, I put together this is a troubleshooting guide for solenoids. And I only made one copy of these in case we needed it, but this is the cable for the setting the K factor on the C-Metrics flow meter. And we'll talk about that in a moment. Okay, so we decide this initiates backwash, sucks up the plunger in number 1, air goes to the hole there, seals off supply, we're filtering through 3. We have about 0.5, 0.6 liters a second going to the reservoir. We have 3.2 going out here in the yard. The reason we know that is it's going to come by with flow meter that's set at liters per second. We screw around all day and watch that at 3.2 yesterday, so we know about where it works. You have a sight glass. Sight glass over time, you have a milligram and a half, 1.57 milligrams per liter of iron. You have 2.11, 0.211, 0.212 milligrams per liter of manganese. These backwash, all that stuff's going to go through here, and over time, some of that's going to stick to the sight glass. Sight glass is really plexiglass. Make sure that the well's locked out. If you undo the screw, it can come out. There's a seal on both sides. What I do is I take my hand and hit it, it pops it off. Usually you can take a soft rag and wipe it out and make it clear again. I like it clear because that's not first time. But the other thing you want to know is you want to be able to see what's going through here. We're going to control the flow is set controlled with this valve. Once it's set, we ran it forward yesterday and had it set at 3.2. Once you set it, it's golden. If something happens and you need to reset it, it's easy to do. You have flow meter to do it at. The other thing you can do is you have an air gap, and you can always open up, they start getting a little median and straighten down until the median goes away. That'll also give you the flow. We didn't have that. If we didn't have this, that's what we would have done yesterday. But we have that, so we chose not to do it. What you're going to see through here, yesterday, as you remember, but yesterday, as you guys remember, is it was pretty nasty and black, and then went brown, and then was gray for a long time. If we backwash right now, I'm guessing it'll be a little bit gray yet. Because of that, that's why we have you over backwash a little bit at first until the rest of the fines get out. But After that, what you're going to see is that it's going to start clear. We're going to start clear. The water above media and in the meter looks clear. And as it comes out, it's going to head out, and so that's going to look pretty. It's going to look about that color. It's going to start getting darker and darker. About a minute in, it's going to get as dark as it's going to get. And then it's going to start getting lighter and lighter and lighter and lighter. That's really important for you to know, because that's your key. What I need you doing is we're going to have you over backwash. We're going to backwash longer than we probably need to, and we're going to backwash a little bit more often. The first thing you want to do is you want to set the duration of your backwash. The way you do that is I come over here. I always set it at 15 minutes. Initiate backwash, start my stopwatch or my sweep second hand, and watch it get dark, and then it's lighter and lighter. When what's getting light, you have 30 seconds to that. That's your ideal backwash time, providing it's no less than 3 minutes. You never backwash any less than 3 minutes. So that's how you know. Otherwise, you could backwash 5 minutes of vessel or 10 minutes of vessel or 15 minutes of vessel. You're not doing harm. You're just going to waste water. No point in wasting water. So that's how you set this. So the first time you're going to adjust it is after it's been line for about 6 weeks. I would want to tell you quit getting that gray color. And doing good removal, that tells you that, okay, it's time to redo this. Yeah, Silly Mac left left us over backwashing, so we got rid of the little bit of lines that are still in here. Next time you're going to, the way you know this works is by what your fresh water quality is. We would like you to be, certainly want you to be at least half the MCO. 0.15 milligrams per liter of iron, 0.025 milligrams per liter of manganese. Really like this supposed to non-detect on both of those possible. So you need to know, sponge, you need to know what your chlorine residual is. What's your chlorine, minimum chlorine residual?
3
No, ignore Marcus. What actually your minimum is supposed to be?
On the answer?
Yeah, out of the finish. 0.5. Give the man a cubic dollar. 0.5 minimum.
That's before the filter, right?
No, that's a post filter. I don't care what you do. If you call me and go, gee, I'm dosing at 3.8, I don't care what, it sounds flippant maybe, but I don't care what you dose. Dose whatever it takes to get a 0.5 3/4. Keep in mind that as your iron, the reason why we want that is that tells us we have enough chlorine to actually iron has a certain chlorine demand, manganese has a certain chlorine demand. There are other constituents in water that have chlorine. The media has a little bit of chlorine demand because we're deactivated. So all those things will affect. So you may do this a little bit. That's why we look for 0.5. If you had nitrogen sulfide and ammonia in this water, we'd set that up and actually have a 0.6 because hydrogen sulfide and ammonia are really volatile and they do swing, and that will keep you from going to zero. Chlorine, backwash. So you have a problem, I'm going to probably ask you several things. I might ask you what your media, it's been a while, what's your media level? And you're going to tell me, we checked it 3 months ago, and this is what it was. I only rechecked it because we were not really sure. And we were still at those levels. The media level should not change unless this changes. You're just not verifying that something hasn't gone wrong. That's why we ask you to check the media level. If you take 6 inches out of each 1 inch, you essentially take 1 filter offline. So that's one reason why that's important. If you're within an inch or 2 either way, we're golden. Don't worry about it. So if you get up there, instead of being down 18 from here, 19 from here, I'm still good. And 20, you might be pushing it, but you can't get by with that.
Have you shut one tank off and checked
Now you just set the well up, it'll take you about 10 minutes, 10 or 15 minutes, you can set all for it. You can't isolate one tank. Yeah, but if you have a problem with one, you have to replace the media, you take it offline, then it's offline for an hour or two, whatever it is that means. So that's what it is. So you call me, I'm going to ask you what. I might ask you about your media level. Then I definitely will ask you what your free flooring residual is. Definitely will ask you. I want to know what you're on, your treated iron and manganese are. What I want to hear from you, if you start having a problem, and usually if you have a problem, backwashing is probably good. But if you can't figure out what's going on, I have good flooring residual. Iron's been running around 0.01 and now I'm up to 0.0203, starting to climb. Or manganese has been under 0.02 and now it's been under 0.01 and now it's climbing to 0.015, 0.017. It goes call me, let's talk about it. It's easier and cheaper to take care of problems than the little. When they're small, it's much less expensive than it is. Every once in a while, I run across someone and their system's gone. In fact, the guy, remember the fellow I had yesterday, that guy used to operate 3 systems and all 3 of them went to pot before. Yeah. So now it was a big deal. We'll have to spend 2 days up working on 2 of his systems because he's got all that stuff. So that's, you're not bugging me, I'm happy to hear from you. Shoot, call me and tell me how wonderful it is. How happy everyone is. They thought the chlorine would be an issue, and the car thinks the water tastes great. And that's okay. You can do that as well. But let me, if it ends up being Thursday or Friday, it's, what about, call me and say, okay, I was thinking, does this work, or does this make sense, or we did this, and is that okay, or, I gave you the most important paper I'm giving you today is my card, call my cell number. The guy in the office knows a lot more than I do, and you want me, call my cell number. Because that's the only way. So that's what we do that. Okay, I learned stuff. Oh, so we've done all that. We talked about even painted. Maintenance summary. I'm going to keep one and then I'll give you the rest of them later. This is our recommended. This is all this stuff you get here is also in your own manual. But this essentially are the things that kind of keep an eye on. Just you kind of get you a checklist. Checking iron, manganese. The other thing I may ask you, if you call me and you have an issue, I'm going to ask you what rate you're backwashing at, and I want to know what it looks like. So what you're going to say is, gee, it comes out clear. It goes to kind of a golden honey color, and it's that way until at this point, and then it quits being clear, and we've been backwashing this length of time. So because that may tell us something that we can otherwise know. So you want to, you want to keep an eye on things and stuff. You want to occasionally, it will backwash automatically. Occasionally, you want to observe the backwash. You want to make sure it's right through all 4. I saw Kevin yesterday about I went out and did some work up the valves and got to the end of it. And they had 6 vessels, and so I initiated backwashes for giblets and grins. Want to make sure everything was working. And 1 backwash was fine. And number 2 backwash just fine. And 3 went off and it backwash great. 4 backwash and it was time for 5 and it was silent. Oh, wait a minute. Wait a little bit. Next thing we know, it's 6 backwash. So, but it had happened, and someone along the way, the dip switch for number 5 had slid in the off position, and they hadn't been backwashing number 5. They're about similar yours, except that it's system been around a long time. It's a metal grade box, it's a 4 box. Don't know how it happened up here. We were able to figure out that they weren't all backwashing. someone from Eastern Washington called me the other day. They were doing kind of the same thing and discovered that they had kicked some media up into one of the valves and it wasn't helping. The controller thought it was working, but they ended up having to pop it open, clear it out, and if you get a really high flow rate, you kick media up, move down the backwash valve. It's unusual for it to happen other than, usually if that happens, it's during startup. And we know they're all working now, so I'll give you this one. The next sheet is simply these have two sheets and they're alternating. This is the troubleshooting guide. It's all the things that it's typical things that you might run across. This is kind of the first go-to. What I would do is I would give a set of these to Eric and get in touch with the laminating one and post it out here. Because usually what I do is I wasn't sure what these numbers ought to be, so I did these just before I left. And I put the troubleshooting guide in the back, and the front is your summary sheet that says, okay, here are treatment goals. I had no idea what these were. It's a good pilot test. But usually what I do is, here's your raw wire quality based on the pilot test. If we'd done the pilot test, these numbers would be different. Would be targeting something different. And then this gives you okay. That way I don't have to do that one. This gives you I was guessing at system pressure based off the submittal information, but well production at 70 ppm. If you want, we can reconvert that to liters per second. We can make it metric, and I can email it out. We can go from there. But you have 4 vessels. They're 18 inch. They have 1.67 square feet of surface. The media is AS741M. It's Barlox. It's 42 inches, so it's 18 inches below the top weld. Maybe annoying, but it's true. So you have approximately 5.85 cubic feet of media in each one of these, which pointing to what Novotech told us, we ought to be able to run these at 10.47 gallons a minute per square foot. We convert that to metric. It's helpful. But the other thing that does give you, and that gives you recommended some those stuff, but what it does give you is it gives you your, that's not true. The backwash valves are incorrect. These are the roads, not the mods. So, but the correct one is in your own manual. Solenoid, that gives you the part number for the solenoid valves. All you have to do is tell me that, but I know who we are, I always look, but I know that usually we either use 73 series or we get to use some 53 series Peter Paul solenoids. These are operational, for an operator, these are much better because you can load these. 53s you can. But then, 3 inch backwash valve, so it gives you tank column number and all that stuff. So, okay, questions? Okay, testing. What you want to know is rosin, chemical room. Right now I did take a raw iron or raw manganese. I said today they're 1.57 mags for iron and 2.1 or 0.211 for manganese, right?
1.51 for iron and 0.211 for manganese.
There you go. So that's our starting point. One of the reasons you need to know that, filters could be working really well, but you know, it's 2016 and we're starting to lose removal. And so I look at the paperwork and you tell me, yeah, my raw iron is running 3.98. Oh, okay. So the problem is your raw wire voltage change. That will affect it a little bit. On the other hand, if maybe at the 1.5 and we just start with integrated removal, and then we're looking at something else. So that's one of the reasons why you want to know it's important to be able to correlate between your raw and your treated. I want to know you treated. We'll do here. I'm presuming that when we get done with the video, that we'll put the valve back in so we can test. I checked chlorine, or we're not getting very good iron magnesium removal, but we inversely have free chlorine residual there, so I'm not surprised. So we did take the pump out when we get down here with this water quality stuff. Are you leaving them the 890 for a while? We're going to leave you the 890. So have you done iron manganese testing? Oh, would you like to learn? Yeah. Awesome. Then we'll go through and you do the water quality testing. And yeah, it's really something. But anyway, what are the questions?
It's good to sample. It's probably good to know if your backwash or not here. It's all goes out into the 2 sediment tanks. Okay. Yeah, I didn't know where to go with that.
Yeah, I think it goes into. You tell me it goes
You can see
into.
it comes out of the building here. Goes across. So these are 2 sediment tanks. So,
Okay.
so if you are backwashing your media out, they'll stay in the tanks. But for some reason you find there's none in there, that's where they are. And then then it goes into a rock pit, which is what you see there. You'll see the grate there.
Yeah.
So it should be fine, but it's just something to also check. You know, if this stuff gets all plugged off in your backwash or not. This is what all it was. It's supposed to go to the ground.
And with the iron you have, it'll settle out pretty quick. So once you get the overflow from this second one, is it going into the drain field or is it?
It's just sort of a rock pit.
Oh, okay.
These are fabric.
But it's underground, so you won't see it. It's going to be pretty clear by the time it gets there.
But then, yeah, there is 2 sediment tanks and other stuff where it all you just pull it out and put it back in.
And disinfect and put it back in. Put it back in, put chlorine in each one, let it sit. Yeah, you can. The best thing is don't backwash it out. Yeah, I have a picture on my computer of a guy in Lacey, Washington, that they had something go wrong, and they backwash into ponds, and the guy's wearing a skeleton, and it happened to be October 31st, 2002, I think. He's out there with shoveling. I mean, they backwash. They have 14 tanks, and they have 5 backwash. Most of the out there, they were shoveling and letting it back in. It's whoops. Not a fun thing. Not a fun thing. So, what else?
Anything on the compressor is pretty strict.
Oh yeah, compressor is
Here.
an air compressor.
Plug it in.
Yeah, we're 100 psi on the regulator. Doesn't take a lot of air. You're using the equivalent of about 16 ounces of. If we were doing this hydraulically, you'd get about 12 or 16 ounces of water out of these. So you're going to get that much air. It's not going to run very often. It's not backwashing that often. This compressor lasts a pretty long time.
Well, maintenance on the airlines going to the valves and whatnot, how often?
Oh, and it's a good question. Let's do this. If you get a little, are you familiar with the snap lock fittings? If you push the tube in, pull the green thing out, it'll come right out. And they all work the same way. This stuff's going to last a very, 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 very long time, and hopefully, they can leave you a lot of extra. But
The whole whack of it on top of the compressor.
oh, there's more there. But if you have one of these leaking, first thing you do is push it in, is it might not be seated tightly. If you take them out a lot, what happens, the end gets chewed up, so trim them straight across and then put them back in, and that'll fix your problem.
Oh, you can go a little bit more of that.
You probably won't be undoing these very often. If you don't undo them, it's not a real big deal. This stuff, it really doesn't wear out very often. So it's, and it's great stuff. But yeah, it's, if you are late on one of the fittings, push it in first, and if that doesn't work, trim it, and get it seated. That will usually take care of the problem. What else? I'm sorry? Okay, let's get Marcus to change out our. Can you give us a valve back?
Now for the hose bibbing.
I'll take care of that water issue after they're
Here's
all of our numbers up those blocks. I'll hang